Welcome, friends. Welcome to all. Today we are study about the new chapter. Okay, that is our new chapter. We are study about the gravitational and gravitation. It is the most important thing. Okay, we know what is the importance of a gravity on the earth. Gravitation. In this chapter we are study about the gravitation, universal law of gravitation, free fall. We are calculating the value of g, mass and weight of the object on the moon. Okay, what happened when we are putting the weight on the object? That very interesting things we are studying. And thrust and pressure. Okay, pressure in fluids binds force. Okay, everyone know about the bind force. What happened with the object when we are through is in the water? Okay, which type of a force acting on that object? That very interesting things we are studying. Okay, why object float? Okay, why object float and sink when placed on the surface of water? That is the effect of buoyant force, Archimedes principle and relative density, gravity. That is the very interesting things. Okay, which type of pressures and all that things we are studying here. Oh yeah, this is the our first point. Before that study we are recalling our points. Those are study is in our career, is in our last studies, last, okay, syllabus. Here the what is the force of attraction? Okay, what is the force of attraction? The force of attraction between two objects. Okay, force of attraction, force when we are applying the force on any object. Okay, it moves without we are applying the force. No any object also react, no any object also move. Here the universal law of gravitation or a gravitation. What is meant by gravitation? The force of attraction between two objects. Okay, the force of attraction between two objects, product of their masses and the universally proportional to their distance square. Okay, that things. Here the important thing is that this is the two object m1, this is the first object m2, second object, and the force acting between attracting between the force of attraction between them. Okay, and the distance from the center of that object, distance from the center of object. Listen carefully, distance कुठून यायला पाहिजे, घ्यायला पाहिजे? From the center of that object, means exact center of that object, that is the D. Here we are studied the force of attraction between two objects, means F is directly proportional to the product of that two object, means m1 and m2, and the universally proportional to the distance between them, means F is directly proportional to m1 m2 divided by d square. Here the F is equal to capital G. Capital G is indicating the what he indicating the gravitational constant, and the distance between two objects m1 and m2 divided by d. Okay, it's about the gravitation. The universal law of gravitation. The law is state that any two objects, okay, here are the two objects, moon and earth, having mass attract each other with the force directly proportional to the product of their masses and universally proportional to the square of distance between them. The force act along the line, okay, join the center of the object. That it's showing the acting the line. This line also red line indicating the that a force of attraction from the center of the earth and the center of the moon, and that was joined by each other, because the force of attraction between two objects means the force of attraction between earth and force of attraction between moon means earth and moon, and the distance from the center of the earth to the center of the moon, okay, that is the capital M indicating the earth mass, the small m indicating the moon mass, okay, and the distance between them. The F is equal to M, capital M, the product of capital M into small m and divided by d square, okay. This is the universal law of gravitation, okay. The Henry Cavendish also state he was found the value of G. What is the value of G? The gravitational constant value is equal to 6.673 into 10 raised to minus 11 Newton meter square, kg is minus square, okay. This is the found by the Henry, okay. You carefully know that and recite it, the value of G, okay. What happened with the here where one note is important, because what happened with the mass, okay, when the object is very large, when any object is very large, okay, the force also need to more, okay, force will be more. When any object is if any object is very small, the force will be less, okay. Okay, here one example, okay. We can pull the bicycle, okay, everyone pull the bicycle, okay, but we can't pull the car. We can push the motorcycle, we can push the motorcycle, but one person can't push the car, okay, because as compared to the size, the bicycle motorcycle size is very small as compared to the car, okay. And let's one more thing. When we are tied one thread, okay, or any rope to the bicycle, okay, we can pull it by the rope or any large thread, okay, we can pull easily from the close distance. But when you are taking the 100-meter distance between your object and you, the 100-meter ropes also we are tied to the motorbike and you can pulling it. You are able to pull? No. When we are pushing to the bike, it is easy because of we are pushing by backside. But when we are pulling bike with the rope, it is not easy to pull because the distance between bike and you, it is very long. means as compared to the push. Okay, means in the gravitation the most important factor is the mass and distance. Here mass and distance, because of when mass are having the heavy, that also acting on the gravitation. When the distance is large, it's also affecting on the gravitation. That two notes indicating that things means mass and the distance are the important in the gravitation. Okay, here what other factors are important, okay, in of a gravitational force, means here it binds us to earth. Everyone know that. Okay, when you can imagine the gravitational force means gravitation is not on the earth, everything was flying is in the sky. Okay, moon revolves around earth due to the gravitational force. Planets revolves around sun due to gravitational force. Okay, tides in a sea are a cause due to gravitational force of a moon on earth. That very interesting things because of the gravitational force. Because of the gravitational force. Next interesting thing is free fall. Free falls means everyone know fall. Okay, when today's rainy days, okay, we are falling dabkas, everyone, okay, sleeping on the mud. Okay, everyone, that happen in the rainy days. Okay, free fall means when we are throwing any object, okay, from the height. Okay, from the height, or the earth also attracting any object toward itself. Okay, the earth also attracting any object because of the due to the gravitational force. When an object moves such that only gravitational force of earth act on it, it's said to do free fall. Why? Because it's freely fall on the earth, only we can't acting any external force on the object. Okay, the classical example of the free fall, you can reach in your gallery, okay, and take a pen in your hands, okay, through from the gallery. Okay, it is freely fall on the road. Okay, when you are in okay, when you stand on the bench, okay, and you are only easily lose the pen from your hands, and that was freely dropped down on the earth. Because of you can't applying the force on that pen, you can't apply the force, any external force, you are not throwing the pen, only you are losing that pens. Which type of force are acting on that pen? Okay, which type of force are acting on that object? That force are a free fall, that force are the gravitational force, and that is called free fall. Okay, here the attraction of earth on object close to its surface, attraction of an object close to any means close surface. Okay, we consider it the any object is really so close to the surface of earth, okay, and we are taking the distance from center of the earth. In a last means, that is the image we are seeing that in last picture we are taking the distance from the center of the earth. Okay, when any object is on the surface of the earth, we are taking the distance from the center of the earth, that will be equal to the radius of earth, that will be equal to the radius of earth. That is, we are taking the radius of earth is capital R E, because of the distance of object is negligible in comparison on the radius of earth. Okay, here we are taking the comparison between the radius and the surface of earth. Okay, because when the any object we are putting on the surface of earth and we are taking the distance from the center of the earth, the distance between surface and that object, it is negligible, it is negligible. That's why we are comparing the distance between the radius of earth and that object here. Therefore the F is equal to capital G, the earth of means we are taking the earth mass, that's why capital ME, small m, that is the mass of that object, and divided by the R square E, where G is equal to capital G capital M, the product between the capital G capital M E, okay, here divided by R square, radius square E. Okay, the G, the small g is acceleration due to gravity, means which type of acceleration due to the gravity, that indicate by the small g. Okay, that is small g is equal to 9.8 meter per second square. The velocity we are studying tomorrow. Okay, thank you everyone.